All right, this is a video on box and whisker plots and also looking at percentiles and quartiles because we need the quartiles to be able to do the box and whisker plots. So a pth percentile, which when we say pth, we mean something like 32nd percentile, 68th percentile. It's representing a value here between 1 to 99. And it's a value such that p% of the data falls at or below it. Now, there are specific percentiles that are called quartiles, and they are going to represent the 25%, 50%, and 75% below. So the 25th percentile, that mark is Q1. The 50th percentile is Q2. It's also our median for our data. And the 75th percentile mark is Q3. Now, the interquartile range, so that's called the IQR, is the difference between the third, so that's the 75th percent, and the first quartile, which is the mark for where we're at. 25% of our data would be below us. And what that represents is that's going to be the middle 50% of our data set. And then when we want to know if something is possibly an outlier, we have this test to do for rule for outliers. The lower limit of whether or not you are beyond that would help us determine if we have a possible outlier would be our Q1 value from our data set minus the 1.5 times the IQR range. And then the upper limit of that is Q3, so whatever that value is at that 75th percentile plus 1.5 the IQR. Okay, so we'll show you how to use that in a minute. Now, if we want to create a box and whisker plot, we're going to need the lowest value, the 3 quartiles, which includes the median in the middle, and the highest value on our data set, plus we'll need that IQR so we can check for outliers. So let's look at how we can create that. So this is the same set of data we've looked at in a couple different problems and videos. This is the number of hours rounded to the nearest 10th that students spent studying for their statistics midterm. So notice I've reordered them this time from least to greatest because we're going to be talking about medians and the quartiles, and that all needs to be ordered data to find that. So we're going to find what we call the 5-number summary. That's used in a box and whisker plot. So the lowest value is going to be 8.6. That's an easy one to pick out. The highest value is 14.0. So how do we find the Q1, the Q2, and the Q3? Because remember, Q2 is technically also the median. To do this, you start with the actual median because it's the easiest thing to find out of those 3 quartiles. So we do the same thing we did in previous sections. So to find Q2, which is equal to our median, we're going to find the position of the median, which remember is the number of items in our set, which is 20, plus 1 divided by 2. So that comes out to 10.5. That means our median is between the 10th and 11th position, and that's because we have an even set of data. So I'm going to mark right here is where Q2 actually occurs. And remember, to find that value, we have to average or find the midpoint between the 2 values on either side of our Q2. So Q2 is not 11.9, it's not 12.2, it's not even actually those 2 values, it's in between them. So if we do 11.9 plus 12.2, find the midpoint of that, so cut it in half. So 11.9 plus the 12.2 divided by 2. We get that our Q2 value is 12.05. So that's what I'm going to write right there. Okay, now we want to find Q1 and Q3. So the good thing about this, and I'm going to use a highlighter here, is that this whole bottom half of the data set, including 11.9, since it's not technically the Q2, that is the half that's going to contain the Q1. And then the whole top half, which I'm going to highlight in blue here, that is the half of our data that's going to contain Q3. So essentially, we are just finding 2 more medians, the median of the yellow highlighted part and the median of the blue highlighted part. Notice that these have 10 items each, so we have an N of 10. So we would do our position for our Q1 is 10 plus 1 divided by 2, so that's going to come out at 5.5. So that's between the 5th and 6th value. So 1, 2, since we're in order, 1, 2, 3, 4, 5, 6. So our Q1 is actually located right in between these 2 guys. So we're going to have to do another kind of average here. So 10.8 plus 11.1 divided by 2. So 10.8 plus 11.1 divided by 2. That is 10.95. So that's my Q1. Now to find my Q3, because remember that's on the top half up here because we already have Q2. So Q3 is going to be still 10 numbers on the top half past the Q2. We're going to have a position again of 5.5 then. So it's between the 5th and 6th of the blue group. So 1, 2, 3, 4, 5, and then 6. So we're going to be looking for Q3 right here. So 12.5 plus 13.1 divided by 2. So we're going to add those together, then divide by 2. We get 12.8. So that's going to be my Q3. Now, the IQR is the Q3 minus the Q1. So 12.8 minus 10.95. This will tell us the distance on our data set, the range essentially that our middle 90% of our data falls into, or not middle 90%, sorry, middle 50%. Make sure I say that right. So the middle 50% of the data is going, which is from beyond Q1 to just right before Q3. That has only a difference or span of about 1.85 hours, since we're measuring in hours. Okay. All right. So to do the check for outliers, we have to first do the lower limit, which is the Q1 minus 1.5 times the IQR. And then we'll have to do the upper limit, which is Q3, the upper quartile, plus 1.5 times IQR. What this is this is a formula to see if the actual lowest and highest values are possibly outliers, or any other values that are close to them are outliers. And what is the acceptable range that our whiskers should travel to in our box and whisker plot. So our Q1 was 10.95 minus 1.5 times the IQR, which was 1.85. So 10.95 minus 1.5 times 1.85. That comes up to 8.175. And notice that our lowest value is an 8.6, which is not lower than this. So we're okay with this will be our whisker endpoint on the lower end. And we're fine with that. Now, if this had been like 7.6, we would stop our whisker at 8.175. That would be the only time we would actually graph that specific value. And then we would put an asterisk member for the 8.6 and any other values, or sorry, 7.6, say it was 7.6. We'd put an asterisk for that and any other values that are below this, okay? Now, you have to remember to switch to Q3 for the upper limit, so that's 12.8 plus the 1.5 times the 1.85, which is our IQR range. So 12.8 plus 1.5 times 1.85, that is 15.575. And our highest value in our data set was a 14.0, so we're okay. So remember, this is just the acceptable range of values that would not be considered possible outliers. So since our lowest and highest value in our data set fall within those ranges, we do not have to have the little asterisks to represent a possible outlier. So our box and whisker plot will be very, very straightforward. So we're going to draw a vertical axis. And usually we'll put a title on this. This is Hours Studying for Stat Final, or midterm, I think is what it was, midterm. And then we have to have our values here. So the lowest we ever got was 8.6. The highest we ever got was 14. So I'll probably count by ones. So we can start, remember, with any value we want. We just have to list it here. So I'm going to start with 8, then 9, 10, 11, 12, 13, 14, and 15. So this represents our hours. And then remember, we need to put our values on the graph. So that's our 5-number summary. So 8.6 is the lowest that our whisker can get. So that's about halfway between 8 and 9. I usually do a call out of those values over here to the side. Our value for our bottom of our box for our box and whisker was 10.95, so almost at 11. So we're going to put a mark there. We'll call that value out as well. The median was 12.05, so just a little bit above 12. So 12.05. The Q3 was 12.8, so almost to 13, but not quite. And then our top value was 14. So when you're done with listing out your 5-number summary, and we've checked that none of those are outliers, so they are going to be the ends of our whiskers, your median is a horizontal line since we're doing a vertical box and whisker plot. So are your Q3 and Q1 values, and that makes up our box on our box and whisker plot. Then we go from the center of the box to the whiskers on both sides. So that is what a box and whisker plot looks like. And that is how you do the check for outliers. I hope that was helpful.